The goal of this video is to understand the meaning of a midpoint and a segment bisector. So before we get to that, we're going to review something from yesterday. Use segment addition to solve for x and find the length of AB and AD. So in this case, for segment addition, we have AB and we have AD that are forming that whole segment with the length of 24. So we would have 2x plus 4 plus 4x minus 4 is equal to 24. We can combine like terms so the 4's cancel out. We're left with 6x equals 24. When we divide, we get x is 4. Then we want to find the length of AB and AD. So 2 times 4 plus 4 is 12, and 4 times 4 minus 4 is also 12, which means that they have the same length, so they are actually congruent. So if they both have the same length and they are congruent, then A would be a midpoint because it's midway between B and D. So when segments have the same length, they are congruent segments. So we could say then that segment AB is congruent to segment AD. This is our congruent symbol. So it's an equal sign with a little tilde over it. So using that idea, we can answer this SAT question. So on PS, PQ is equal to RS. What is the length of PS? So if PQ and RS are equal, that means they're congruent. They have the same length. So for now, we're going to ignore the x in the middle, and we're just going to use x minus 1 is equal to 3x minus 7. So as we solve, we can add 7 to both sides and subtract x from both sides. So we get 6 equals 2x. And we divide x is 3. Then if I want to find the length of PS, 3 minus 1 is 2. X is just 3 here. And then 3 times 3 minus 7 is also 2. So to find the length of PS, we would add those three pieces together. 2 plus 3 plus 2 gets us a length of 7. So a little more vocab words before we get into midpoint and bisector problems. So a midpoint is a point that divides a segment into two halves or into congruent segments. So you can think about it either way. So if M is the midpoint of AB, that means it's going to be divided into two congruent parts. So AM is going to be congruent to BM. A bisector then is a line, a segment, or array that divides a segment into two halves or two congruent segments. So in this case, L is going to bisect at M. So M would technically still be the midpoint, but we have a line going through the midpoint, but it's still going to create the same end result. AM is still going to be congruent to BM. So number 1, M is the midpoint of AB. AM is 3x plus 5, and MB is 6x minus 16. Solve for x and find AM and AB. So if M is our midpoint, that means this segment is bisected into two congruent parts, so we can set them equal because we both have a half of a line here. So half of a segment. So 3x plus 5 is equal to 6x minus 16. We can subtract 3x from both sides, and we can add 16 to both sides. So we get 3x equals 21. When we divide, we get x is 7. So then we want to substitute. So the length of AM is 3 times 7 plus 5. Well, 3 times 7 is 21, plus 5 is 26. And then we have 6 times 7 minus 16, which is also 26. And this should make sense because they are congruent, so they are going to be equal. So if AM is 26, our whole segment AB is going to be 26 plus 26, which is 52. So this whole segment is 52. In number 2, M is the midpoint of AB. So again, this is bisected. We know that AM is 2x minus 8, and AB is 3x minus 4. Now, these are not equal because this is only half a line. The 2x minus 8 is only half a line. So we know if they are congruent, though, that this other half is also 2x minus 8. So when you have a half, you need 2 halves to equal a whole segment. So we're going to do 2 times 2x minus 8 is going to equal 3x minus 4. So distribute the 2, 4x minus 16 is equal to 3x minus 4. We can subtract 3x from both sides. X minus 16 equals negative 4. When we add the 16, we get x is 12. Once we know x is 12, we want to find MB. So MB is 2 times 12 minus 8. So 2 times 12 is 24 minus 8 gets us 16. So MB has a length of 16. In number 3, C is the midpoint of AD, which means this is half of our segment, and this is half of our segment. B is the midpoint of AC. So if you're taking a half and you're splitting that again, that means that each part of the line is 1/4. AB is x plus 2, and AD is 5x minus 2. Solve for x. Find BD. So if we know that AB is a fourth of the line, that means we need 4 to equal our whole line. So we're going to do 4 times x plus 2 is equal to our whole segment, 5x minus 2. So when we distribute, we get 4x plus 8 is equal to 5x minus 2. We can move the x over to the other side, so 8 equals x minus 2. We can add 2, so x equals 10. Once we know x is 10, in order to find BD, we know AB and we know AD. So what we're going to do is we're going to find the whole length of both of those. 5 times 10 minus 2 is 48, and 10 plus 2 is 12. So BD is the whole rest of the line, not including that 12. So to find BD, we can do the whole segment minus the little segment. So BD is going to be 36. Now, using the diagrams, what's true? So looking at our fractions here, AB is equal to CD. Well, AB is a fourth of the line, and CD is half the line. So that's not true. BA equals BC. Well, BA is a fourth, BC is a fourth. That's true. 2BC equals CD. So 2/4 equal a half. That's true. 4BC equals AD. So 4/4 is equal to the whole segment, which is true. AC is equal to CD. Well, AC is half the line, CD is half the line. That's true. And then 4AC is equal to AD. Well, AC is half the line, so 4/2 is going to be too much. So that's also not true. In number 4, draw a diagram that shows R is the midpoint of GH. What conclusions can be drawn? And then we're going to solve for X. So when we draw GH as our whole segment, we put R in the middle. If R is a midpoint, that means it's bisecting this segment. So we can conclude that GR is congruent to RH. Okay, then we know that RH is 7x plus 9, and we know that GH, this whole segment, is 18x minus 2. So if the whole segment is 18x minus 2 and half is 2x plus 7, we need 2 halves to equal our whole segment. So we have 2 times 7x plus 9 is equal to 18x minus 2. So we get 14x plus 18 is equal to 18x minus 2. We can subtract the 14x, so 18 equals 4x minus 2. Add the 2 to both sides, 20 equals 4x. So when we divide, x is 5. In number 5, draw a diagram that shows C is the midpoint of DF. Solve for x. So again, we have our segment with D and F. C is the midpoint, so it's halfway between each endpoint. We know that DC is 5x minus 13, and CF is x plus 3. This time, we're given the 2 halves of our segment. So if they are both halves of the segment, they are automatically equal. So 5x minus 13 is equal to x plus 3. So we get 4x minus 13 equals 3. We can add 13 to both sides. 4x equals 16. We divide, x is 4. In number 6, given that WT is congruent to HS, determine if WT is congruent to BD. Show all work and explain your answer. So right now we know that these two segments are congruent. And when we know that they are congruent, we know that they have the same length. So we can set them equal to solve for x. So 4x plus 10 is equal to 5x minus 3. So as we solve, 10 equals x minus 3. X is 13. Okay, now we want to figure out if WT is congruent to BD. So remember, to be congruent, they have to have the same length. So we're going to substitute in 4 times 13 plus 10 gets us a length of 62. Now we need the length of BD, so 3 times 13 plus 23 is also 62. So because they have the same length, they are congruent. So we would say WT is congruent to BD because the segments have the same length.